What's going on, guys? Savor Sauce here, back with another video. Today I'm going to be taking you guys through a Kaggle competition. It's going to be the Spaceship Titanic. I'm going to take you all the way from, making a title for your Kaggle notebook to whatever. I am going to be doing all of this on Kaggle. I'll leave a link to my notebook in the description if you just want to read through the notebook instead of watching the tutorial. So anyway, we're just going to get started here. So first things first, I'm just going to name the notebook Spaceship Titanic Tutorial. It doesn't really matter what you name it, I'm just naming it something. And then something important here is on this little tab right here where it says data, you're going to want to click add data, click Spaceship Titanic. Spaceship Titanic is right here. Just add the competition and it'll get you to be able to submit. So now it's added, you can see we have the data. Now just run this cell, it'll start up the notebook. You're going to need to start up the notebook to get any of this done. It's almost like it doesn't really matter how powerful your computer is because it runs it on the cloud, I guess. It runs on their own servers, so it's not of any cost to you. So here you can see the path files. We're going to need the sample submission, you don't have to worry about, but we're going to need the train and the test data. So first things first, let's make a data frame, call it train df equal to pd.read csv, and then we're just going to copy and paste this right here. Make sure to put these in quotation marks as a string, like that. Now we're going to do the test df, equal that to pd.read csv, and then we're going to put the test in here. So we're going to want to manipulate this data just to make sure that we have the all the missing rows accounted for, and we're also going to want to deal with it in such a way that we have all of the we want the data frame to be together is what I'm saying. So we're going to combine the train data frame and the test data frame. We'll separate them later, but to separate them later, we're going to need to get the links. So just going to do train length equal to the length train data frame, and then we're going to do the same for the test. This is just so that later on we can separate them easier. Alright. Now we're going to instantiate some functions. So I'm just going to copy and paste these, and I'll explain what they do, like this. Alright, so basically what we're doing is in the combine one, we're just concatenating the train and the test together and ignoring the index, and then we're giving back the combined data frame. And in the separate data frame, we're taking the combined one along with the links and separating them based on where the links are. So you can see that now our data frame has a length of about 12,000 rows, which is very good. That's a lot of training data we can use. So now we are going to deal with a missing column called cryosleep, or rather we're going to deal with a bunch of missing columns. So we know that people that are in cryosleep, if you look through the data, they're not going to be buying any money because they're going to be in stasis, and there's a lot of different money columns, so we can just fill in all the money columns. So what we're going to do here is we're going to type in 0 columns, and then we're going to leave this equal to room service, food court, shopping mall, spa, and yard deck. These are all the columns that deal with money, because these are all the columns that deal with money. And we're going to do the same. So our condition is equal to this. Hold on. Equal to true. So if cryosleep is equal to true, then all of these need to be 0. So now I'm just going to copy and paste this code because I don't want to write it all out. I don't want to waste you guys' time. So here we're locating all of the columns that have this condition, and the 0 columns and we're making them equal to the same thing, but we're filling it all in with zeros. And then we're making all the false columns. Hold on. I just noticed we didn't put in false columns. So there's only one, it's just VIP. Because people that are in cryosleep don't pay for VIP. So now we're just going to run this. And that should deal with a lot of our missing values. Now we're going to deal with the so for the people, so now we're going to deal with cryosleep missing values, because if people aren't spending any money on any of the money columns, for example, if they're not spending any money on food court, we know that they're probably not awake, because people that are in cryosleep aren't going to be eating. So we're just going to fill in all of the cryosleep columns with false or true if all of the zero columns are equal to 0. So I'm just going to copy and paste this, and then I'll explain it. So here we have the same columns, 0, cryosleep, and then our condition this time is if the 0 columns are all equal to 0. And then whenever they are, we just fill them all in with true, so that the cryosleep column is all true. So now, the only values that should be left are people that aren't in cryosleep. So we're just going to fill in cryosleep as false for the rest of them. And we're just doing this because cryosleep I found to be an important column when it came to predicting. So now, when we look at the actual data, you can see that all of our cryosleep columns are 0, so we don't have any missing numbers, which is good, so that's one out of the way. And then we dealt with some of these other ones, so the missing values in general are looking a lot better. You could do this with pipelines and it would be quicker, but this way is smarter, so it's a lot better. Alright, so now we are going to deal with the cabin column. So we're going to the cabin column. If we go here, let's type just to get the head of them. So if you see the cabin column, it's got a bunch of different values in it. This can't be processed by the machine learning models, or at least it can't be processed by like XGBoost or random forests. So we're gonna have to separate these. It's pretty simple, just because they're all separated by that slash character, so we can just separate it by the slash, which is what we do here. We split the string on the slash for all of the cabins, so that way we're getting the cabin. So this is the split. So now we're getting a list of each value in here, and then we're naming them as deck, room number, and side, and then we're concatenating them onto the data frame, changing the full data frame to the new data frame, dropping the columns for cabins since we have new columns for them. So now let's see what this does. Alright, yep, here we go. So it's got deck, room number, side, just like we wanted. This will make things easier. It'll probably, I found that the cabin columns are pretty useful, and we want to keep all of the data and make it as useful as possible. So now we're going to get the average age based on home planet and who's in cryosleep, and then we're going to fill them in. But first we need to get the means. So here you can see we have the means for each. Very useful. Now we're going to fill it all in. So I'll explain this code in a second. Alright, so we are grouping by the home planet and then the cryosleep. And then we're getting the average. And we're naming it the mean, the average age. And then we're merging it based on home planet and cryosleep. And then we're just filling it in based on those columns. And then we're dropping the average age because we don't need it anymore. We just had it there so that we could fill in the values better. So now we're going to run this. Alright, by the way, I'm just clicking Shift Enter. Whenever I run them, you can just click this right here if you don't want to do it that way. So now the age column should be completely filled in. Yep, just 5 missing values left, which is fine. It's nothing to worry about. As long as you fill in most of the values, you'll end up a lot better. So we didn't deal with all the missing values. As you can see, we have a lot. So to deal with them, we're just going to use a pipeline. So here's the pipeline, just column transformer, standard scalar, one-hot encoder, simple imputer. And we are separating the numerical features and the categorical. You can just copy all of this since it's the same. So this is the pipeline for dealing with numerical values. This is the categorical pipeline for dealing with category values. And then we're putting it all into the preprocessor using the pipeline and the features. So now we're just going to run this. This doesn't do anything. We're not transforming it yet. We're just putting that down. So now, this is why we made the separate data frames thing earlier. We're making a train data frame and a test data frame and separating them. And then we're making the Y value. This is what we're predicting, whether or not they were transported. And we just set that as the train data frame for the transported. Since the test data frame doesn't have a transporter, we have to make it based on our predictions. And then we're dropping the column for transported, and we're dropping test data frame, because when we join them together, it just made a transported column and set them all equal to not a number. And we can't have that in the prediction, so we're just dropping that on the test as well. Then we're converting the Y to a Boolean, because it's actually a string before this. So now let's check. Don't worry about this, this is just a warning, it's not an error. And now we can see that these are all booleans. It says it right here, data type bool. Alright, so now we're going to bring in the pre-processing. So I'll just go through this data line by line. So we're fitting the transformer to our train data frame, and we're also transforming it. That's why it says fit transform, and then we're using the preprocessor that we already fit to transform the test. Here, since whenever we transform them, all of our feature names got lost. So here we're just adding back all of the feature names. That way it, this is just holding all the feature names. And then we're just adding them, because the numerical features weren't changed. So you'll see that in a second. We're just going to run this first though. Now, because it transformed it, it's no longer as a data frame, but we need it as a data frame to see how the columns are now. So we're just transforming them, and we're using the columns that we just made, all the feature names, as our columns for both of them. So now we just run this. Alright. Let's just see what our... Let's just check one, just to see how it looks, so I can show you here. So here you can see all of the numerical features stayed the same in terms of money, and these are encoded. So now for every category on the categorical, there's a feature for it, and if it's true, it's a 1. So whenever their home planet is Earth, it marks it as 1, or else it marks it as 0, and it does that for all of them. You can see we have 27 columns now, which is not bad. That's reasonable. So now we're just going to keep moving. So now we're going to make our model. So here we're going to be making an ensemble model. Each of these models that I'm about to add is already an ensemble, but we're combining them to get a better result on average. This is just a random forest model that I was testing out that ended up hurting the model's performance, so we're not using it. Here you can see we have 3 different gradient boost models, and they have roughly the same parameters, except some max features is different, and then the loss is different. So we're just going to run this to instantiate them. This isn't the training, it's just instantiating the models. Seed. Seed is not defined. Alright. So we set a random seed before. So we're going to name this seed, and it's going to set it equal to 42. It doesn't matter what number you set, it just needs to be the same across all of them. See, you can see that it's all set to seed. Alright. Now, we are going to split our data using train test split, which we, I believe, imported up here. No, we didn't import it. Okay, let's import train test split real quick. From sklearn model selection. import train test split. Now we are going to split our data, just like that. Alright. Now, this is going to be a big piece of code. I'm just going to explain what it is that we did, just to explain how it works. So here we're importing an accuracy score. This is just a simplified version of getting how accurate our model is. We're fitting all three models to the X and Y train data. Then we're predicting the X test data. Then we're stacking the features. So all of our predictions are being stacked together to be features for another model, which we're having is is called a meta model, because it's ahead, meta meaning essentially above. It's the final model that makes the actual predictions based on the predictions of the other models. So we're using a logistic regression with no parameters being changed. Then we're fitting it to the stacked features, and then the actual predictions, just to see essentially how powerful the model is. Then we're predicting for the test, and then we're stacking all the predictions, and then we're making the final predictions and then testing it. So if we run this, 80.4, this is an 80% accuracy, which is not bad. That's pretty good. But this was just running off of the train data. We trained it on the train data, and now we have to use the actual test data that we made earlier. So now this is going to be a lot lighter of code. Right here, you can see we have the base predictions for all the three, and we're just predicting the same way we did before. Then we're stacking the predictions the same way we did. It's just the same thing right here, except we're using different data to predict on. Then we run that. Now we're going to create the same thing we did up here. We can just copy and paste this code right here. Except this time we're using... Nope, we don't have to change anything, because we already reassigned the values. So we just run this, and that's it. That's our predictions. If we look at ensemble predictions, like this, you can see we have a list of values. So whenever we submit, we need to have it as an actual data frame, because we need the IDs as well for all the testing. So we're going to write output is equal to pd.dataframe, just like that. And we're going to actually list them out. So passenger ID is just going to be equal to the test data passenger ID, because that's what we're predicting. Now we're going to use transported, which is the column name that we need, equal to ensemble predictions. There you go. That's it. Now we just need to output this to a CSV. Name it submission CSV, because it needs to be sent in. Just like this. Now we're gonna print out that it was saved, just to see that everything worked the way it was supposed to. Just like that. Alright, so now we're gonna get to submitting it. So we just submitted the save. If you look in the output, you can see there's a CSV file called submission. Oh wait, hold on. There's an error right there. Alright. Just can delete this. Oh, you can't delete it. It's no big deal. Just don't worry about it. We have our CSV file. Now we're going to save the version like this. So you just click up here, save version. We need to save our version because we have to save the output. So with the output, you'll see it's just running through all the code again to make sure the whole notebook works without fail. It doesn't get an error somewhere. And once this finishes running, I'll show you how to submit to the competition. So here you can see it was successful. Now we're going to click on this. Click go to viewer up here. Then we're going to click on the output folder. You can see we have all of our data. Now we're just going to submit. I'll just say this is tutorial as the description. And then we're going to submit it. And there you go. 80.126 is our competition. If you look on the leaderboard, that puts us somewhere down there. Maybe in 500th, which is not bad. Keep in mind this is a rolling leaderboard, so it's not, perfect. But no model will ever be perfect, so it's not that big of a deal.